Welcome to the Static Malware Analysis series powered by Azefox Innovations. In today's video, we are going to have a look at antivirus scanning. Before executing any suspicious file, cybersecurity professionals often perform static analysis. This is the process of examining a file without running it to identify potential threats. Think of it like inspecting a sealed package for suspicious signs before deciding whether to open it. The goal is to spot malicious indicators early, without triggering any harmful behavior hidden inside the file. So here we start with the static malware analysis 101. Static analysis can reveal a lot about a file's nature. Analysts start by extracting strings, which are the readable text inside the file, which can actually contain information like URLs, command line instructions, or even embedded credentials at rare scenarios. The file structure is reviewed to check if it matches the expected format for its file type. Technical details like imports and headers are examined to identify what libraries or system functions the file might attempt to use. Sometimes security analysts will also check the detection ratio by scanning the file through multiple antivirus engines to see if it is flagged as suspicious or malicious. So now we enter the antivirus scanning 101 part. Antivirus scanning is one of the fastest ways to detect known threats. It operates using signature-based detection, which searches for exact matches to patterns from known malware, and heuristic-based detection, which looks for behaviors or traits that are statistically likely to be malicious. This combination allows antivirus products to catch both previously known threats and some new similar-looking variants. Popular antivirus engine includes Windows Defender, then we have Claim, AV, Sophos, then we have the McAfee and Kaspersky, etc. Now we'll have a look at how the antivirus scanning actually works, right? First when a file is scanned, the antivirus engine checks multiple characteristics. It compares hash values such as MD5, SHA-1 or SHA-256 to a database of known malicious file hashes. It analyzes byte sequences, also called signatures, which are unique code patterns present in specific malware families. The file metadata is also reviewed. For example, whether the file has been packed or obfuscated to hide its code, its size compared to typical safe files, and which functions or libraries it imports. Once the scan is complete, the antivirus engine produces a verdict whether it is clean, suspicious, or malicious, and may assign a detection name that links it to a known malware family. Here are some of the commonly used antivirus tools for antivirus scanning things, right? So security analysts use a variety of tools for both static analysis and antivirus scanning. VirusTotal allows users to upload files and have them checked by dozens of antivirus engines simultaneously, often revealing a detection ratio across vendors. Any.run provides an interactive sandbox environment to see how a file behaves in real time, while hybrid analysis offers in-depth reports combining both static and dynamic results. Open source tools like Claim AV are useful for quick scanning, and YARA rules can be custom written to identify files that match specific patterns or characteristics defined by the analyst. So here we have a small demonstration about scanning a malicious file, using VirusTotal. I have a site here, something known as the Malware Bazaar, right, which is actually a database containing of many malware samples, right. The malware sample that we are going to have a look here is something known as the Remco's rat. Here I have the hash value for the Remco's rat, which has been recently uploaded to this Malware Bazaar. This is the hash value of the Remco's rat. Let me copy this, right? And here we have the VirusTotal, as what I said, which is actually a really helpful tool for antivirus scanning and also for static and dynamic malware analysis too. Right. Here we have multiple options whether you can actually upload a file, you can submit an URL, and also you can search here using again you can submit URLs, IP addresses, domain names, or even file hashes. Right. So let me paste the SHA-256 hash of the Remco's rat and let me search this. And as you can see, it currently has around 62 security vendors, right, the antivirus engines that been associated with VirusTotal. And out of the 62, only 2 of the antivirus engines actually detected this as a malicious one, as a malicious file, right? As you can see, it is associated, or it is like affiliated with almost like all of the top antivirus engines, right? And if any file is malicious, it will definitely flag that as malicious, right? And for 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 some other purposes, I can actually uh, show you another example. For example, we can scan a domain like google.com. It will check that whether this particular site is malicious or not, and as you can see that this particular www.google.com is not malicious, right? And it hasn't been flagged out by any of the antivirus engines. If in case this particular site is suspicious, it will also make this, or it will also flag this as malicious too, right? Now we will focus on the limitations of antivirus scanning. While antivirus scanning is powerful, it is not foolproof, by the way. Polymorphic malware can constantly change its code to avoid signature detection. Encrypted or packed payloads can conceal malicious code until they are executed, making them invisible to static scanning. Custom built malware may not have any existing signatures at all, meaning it can go undetected by traditional antivirus tools. Most importantly, antivirus scanning only matches patterns. It doesn't confirm actual behavior. This is why deeper analysis such as dynamic analysis in a controlled sandbox is essential for a complete picture. So the conclusion of this video is static file analysis and antivirus scanning are crucial first steps in malware investigation. They allow analysts to quickly identify obvious threats, gather intelligence, and decide whether deeper behavioral analysis is required. While these methods have limitations, they provide a safe, low-risk way to spot red flags before any damage is done, making them a key part of any cybersecurity workflow. Thank you for watching the video. We'll catch you all in another video. Bye. And follow and subscribe Azefox Innovations for more informative videos. Bye.